who has questions? So what we'd ask is if you could say your name and company and ask away.
Mark Hosky, Control Engineering. Could the last speaker talk about ROI as it relates to the investment and what you've put into the product and the anticipated $1 a barrel?
I'm sorry?
ROI.
The payback time. Oh, the payback time? Well, the payback time is almost immediate. But once you claim it, I mean, sometimes you can't say it's over the whole year. It can be for different areas. I'm sorry, the mic's not. Oh.
Do we have mics on?
Okay, the payback time was almost immediate. Once you make the changes, you've now capitalized on that gain, and that gain, hopefully, you can continue. Once the automation part of this comes into effect, then basically we can go right up to the $1.
Okay. One of the things I did want to do for the panel of experts, if each of you, before we continue with questions, if you could give us 1 or 2 minutes and just explain your background and what you've done in industry, because you all come from diverse backgrounds. Maybe Lloyd, could you go first and just talk a little bit about your background?
Yes, I'm the worst of all cases. I'm a chemical physicist working in a chemical company. What I did was I started out in R&D doing product development, and then I got curious about manufacturing because it didn't seem to be efficient, and walked into manufacturing and have been trying to, ever since then, apply better analytics and better science to our plants. And currently I'm leading a fundamental problem-solving initiative within the corporation and a higher order data analytics group.
Tom?
Yes, good morning. I've had all of my career on the supplier side. Had the good fortune to work with a collection of really great chemical engineers early in my career. Greatly reminded of that experience from Lloyd, because one of his key messages is there's no substitute for knowing what you're doing. And so I had the good fortune to learn from some really great people. But for most of my career, I've been involved in advanced process control, and the last few years I've taken responsibility for our optimization business worldwide.
How about you, Cliff?
Yeah, my name's Cliff Peterson, and go back a long ways. I've always been on the owner-operator side of the equation. Always in oil refining. I took my chemical engineering degree in the late 60s and got involved with hooking up some of the first computers to refinery processes and the instrumentation and the valves, and doing the programming, some of it in assembly language, if you remember that. Along the way, that was with Imperial Oil in Canada, which you would know as Exxon now. It's still Imperial Oil in Canada. And then primarily in the Sarnia refinery, which was Canada's largest refinery at the time. And then moved to Shell, and where I led the adoption of computer control in Shell Canada. And we started out with a chemical plant that we were building in Sarnia. And then I moved to Suncor, Sunoco refinery in Sarnia, which was a real opportunity, and to bring in process control, computer control, advanced process control, primarily dynamic matrix control. I hired Charlie Cutler when he was a two-man company. I hired Steve Treiber when he was a two-man company, helped me do that. And then along the way put in real-time optimization on top of that. Very flexible refinery. It's the refinery Perry's talking about. Actually hired him too along the way. Because it's, we always oversold the refinery because it was an opportunity to market in southern Ontario. We were able to get a lot of flexibility in the operation that led the way to implementing real-time optimization. And we did that quite successfully. At the end of my Suncor career, after 24 years, I was involved with responsibility for all the product production applications across the whole company, and that included the oil sands plants up in Fort McMurray and the Denver refinery and the like, as well as Sarnia. And then after retiring for a couple of years, I went to work for Northwest Upgrading, and they're the company that's building a new refinery outside of Edmonton to process soil sands bitumen directly into finished product. And I was the CIO of that company, and we designed the computer systems to dovetail very nicely and give the platform to do all this good stuff when they finally get the refinery started up. That's enough, Peter.
Thanks, Cliff. Stephen, how about you?
I'm a chemical engineer, and I taught myself how to program computers in 1963 when I was in high school. Only in order to do it, I had to build a computer. So I saved my allowance to buy a Sinclair computer kit, and I built it, and then I wrote the 3 or 4 programs that you could actually implement on the Sinclair computer. And then I was stuck because there was nothing else I could do with it until I got to university when I got my hands on a real computer. And that's what I've been doing all my life at Scott Paper Company, Shell Oil, and Triber Controls, then AspenTech, now Manufacturing Technology Network. I make stuff, software, to try to make money with models in processes.
Thanks, Stephen. Perry, a little bit about you.
Okay, I started my career not as far back as Steve, but about 1981. And I started with Shell, and actually I worked with Steve and Cliff at Shell. Was there for about 13 years working process controls. I was in process also, and then I moved to real-time optimization and did a number of projects there. About 93, 94, I moved down the road. Cliff hired me at Suncor. Went in and did again real-time optimization, but then had an opportunity to move into planning. Ran the monthly business plan, for about 5 years, I think, for them. And after that, moved into more business development role. Again, using their linear program, I did strategic work in the way of major projects and asset acquisition. And about, after the merger with Petrocan in 2009, I moved back into process control area, which, boy, had changed a lot in the 15 years I'd been gone. But it's been a pleasure to be back there again. And this project has kind of brought me down all the different areas that I've worked so far. So that's kind of about my story.
Great, thanks.
It's real funny, Peter, because every time the planning and scheduling group needed an engineer that could understand an LP, they came and robbed one of my engineers. Perry was one of them. Did a good job, too.
Okay, so you can see that we have a lot of talent in one spot. So let's capitalize on what they've got to say about optimization. Just please state your name and your company.
Glenn Pounders. I'm with Shell Oil US. I'm so envious of you guys in Canada with your advantage crude. Anyway, so my question is for Lloyd. Help me understand. I might have misunderstood, but at the end you gave some examples of how you're creating value, and it seemed like it was centered around operator instructions and better improving the way operators interpret some alerts and react to alerts. Is that correct?
That is one aspect. In a 20-minute talk, I had to go through that pretty quick. I'm sorry. But we really our goal was to improve the conversation around the data at all levels. And that, on an operational level, we already had various systems in play to analyze data, and that was going pretty well, but that was just day-to-day maintenance. And so I think our big breakthrough was to engage R&D organizations that were typically kind of separate because they weren't really in the plant. They were obviously doing other things as well. And then engaging other experts within the company that are leveraged, but out of, for example, modeling capabilities, engineering capabilities, bringing them all to the same data place, tailoring their personal view of what they want to see, and then moving forward with those types of dashboards. And that's the next step. Obviously, eventually, I would like to be able to get to a point where, just like if you're looking for a vacation on Maui and you start Googling it, Google notices you're doing that and starts asking you questions or giving you ads on the side. What I would love to see is the technical information start popping up the minute that engineer or that operator gets curious about something the system's telling him about or her about, and brings that information back to them. So what I showed you was effectively our initial steps and what we're trying to implement now. and it's actually working quite well.
Great, thanks. I have a question that has been on my mind for a long time. I started this presentation thinking about technology and business process, and ARC's been following this topic for a long time. So we struggle with getting the business case together for real-time optimization, and many operators shut off multivariable controllers, and they struggle with keeping these things. What is fundamentally wrong with this industry, and where are the areas that we can make improvements in technology to optimize? And this is really just an open question to anybody on the panel that has a strong opinion on this.
Sure,
You go on that one first.
I'll take a whack. So I've been trying to do this for maybe the longest, almost. Yeah. Looking back, I realized that one of the biggest problems that we have as process automation engineers is monetizing what we do. We would make presentations. I remember when I worked at Shell, we would make presentations to our management, and inevitably one of our vice presidents would say, "This is really complicated." And we look at each other and say, "Yeah, it is. Wow, that's great." Well, because we thought that was a good outcome. He got it now. He realized it's complicated, how much he needed us. So the real issue is to be able to monetize what we're doing. That's what the business leaders of certainly oil companies and chemical companies have been asking of us all these years. What's this really worth? What's it worth to me to pay all you people with PhDs and master's degrees and have all of this complicated technology and computers and things? And remember, back in the 70s and 80s, none of our managers had ever touched a computer in their life. They were afraid of them. So, it's much different now, of course. But what they want is to be able to monetize the value, whereas they can monetize the value of building a plant, putting in a new cat cracker, installing switching their ethylene crackers from naphtha to gas because the market's changed. What's the monetized value of what we do? Okay, and not to, I don't want to make this a commercial, but that's this new technology that we developed. That is the inspiration for it, because when I sat in my business partner Ron McLeod's swimming pool 3 years ago over a few drinks of scotch and maybe some other alcoholic beverages, we asked ourselves, what went wrong? And that was the number one thing, was we couldn't tell them what this was really worth. If they turned it off and threw us out the door, or assigned us to go and clean the units, what would they be losing? That's what they wanted to know. And this is the real, and you hear people talking about KPIs and so on. In the end, they've always got to be associated with a value in dollars. That's our real challenge.
Yeah, that's right. But let me say it in a different way. It's about the business. It's about the business drivers. It's about what you're doing to improve those business drivers. And that's what management wants to hear. If you can express it in dollars, really good. But as I had one refinery manager challenge me one day, he said, "Show me where it is in the tanks." And if you can't do that, you're on pretty thin ice, as we say in Canada.
Tom?
Yeah, I'd like to share some perspectives on this as well. I mean, certainly Steve and Cliff are dead on. I would extend their statements to say, and again, as a supplier, I get to see this sort of argument play out in a variety of industries, and not just refining. And I think as a group, historically, the royal we have done kind of a rotten job of expressing the benefits in the business terms that they've mentioned. But there are a number of other factors as well, and I think that going back to your original premise basis here is that, if you were to construct a root cause analysis chart, certainly, the business implication, and that certainly has to be convincing and credible to the refinery management, because they have to, allow the resources to continue working in that area. But operators don't understand what these systems are doing. If owing to the multivariate nature, if one of these systems, whether it's an optimizer or an APC, is making moves that that an operator doesn't understand, the safest thing for him sometimes is to say, I'm not sure what's happening here, but I think I'll switch it off just in case. And so there's sort of a passive-aggressive thing going on there. And so, and I think that plays back to Perry's point about making sure everyone has a deeper understanding of what's going on in the first place. We also see that a lot of these systems over the years historically have been pretty hard to use and fairly cryptic. I wouldn't even say they rise to the ease of use level of a spreadsheet. And so, we have a new generation of users coming into the marketplace now, and they have high expectations due to smartphones and iPads and these kinds of things. So I think there's a real opportunity for us to bring a lot of ease of use and particularly integration between applications. I think the gentleman from Exxon yesterday made a wonderful point. He says, we can never make mistakes on the process that we never have to do, the work process. So integrating data, whether it be LP vector exports back to a planning system or data reconciliation validation done automatically and robustly, but all those work processes that can be integrated and automated under sort of a new generation of ease of use, I think are all valuable, important steps.
I'll add something to that. And Peter, there were, I think, 3 keys to keeping my applications online. And that's the key to it. Once you've got something that works good and you can show management where it's improving the performance of its plant, you got to keep it running. Number 1, make sure it helps the operator. Make sure it helps the operator. If it's doing a good thing for the operator, he'll keep it turned on. Number 2, make it visible. And spend time in the control room and explain why it's doing what it's doing. And that takes face-to-face. You don't do that with emails. This is a social thing. It's people. You've got to make sure make it visible and explain it. And then thirdly, make sure that management comprehends the value, and then they will make sure that operations management, they'll ask operations management why it isn't on, and operations management will ask the operators why it isn't on. And if all those things are in place, it'll stay on. And I think we saw that in Sarnia. I hope it's still that way, Perry.
I just want to add one thing. All of us work in a business, and the business is out there to make money. So if we can demonstrate that we can make money, and with the tools that we have at hand, obviously they're going to keep us. They're going to want these tools. They're going to want better tools. There's going to be opportunities out there to make money, and if we can demonstrate that with our tools we can help them. Like, for example, opportunities arise in the refining business. They may happen overnight. If we can swing our operation around to be able to capitalize on that with the tools we have at hand, then we're going to make money. And I think at the end of the day, that's what we want to see.
Okay, finally, I just have to speak. If you implement something new and it's wonderful in the plant, you've got to take away the alternatives to shutting it off.
Good point. Are there any other questions from the audience? We've got all this talent in one spot. I'm sure they're dying to give you answers.
So what's the most common mistake that people are still making over and over again that just makes you shake your head?
Where do I start on this? I guess the most common mistake is getting mired in the data and not trying to figure out where the real value is.
I would say it's the same mistake that's been made from the beginning. Forgetting the process, the word process in process automation. The businesses and the processes are so complex. The layers of technology that we've introduced can sometimes mask what's at the core of the entire thing, which is the processes. Right? That's the business, and too many control engineers forget the process part of their job.
I'll underscore that. I used to tell every engineer that came to work for me that the reason the refinery was here was not so that you could play with computers. The computers were here to help that refinery run better.
Yeah, and I just wanted to say that, it occurs to me as I'm listening to the great comments here that, sort of a bit of a side analogy to try and answer the gentleman's question is, along towards in the 70s, and certainly by the time the 80s got here, these digital control systems got put in pretty much everywhere. And the suppliers of these and, configured or offered all of these alarms to be configured that weren't available in the electronic or analog systems. And so everyone said, well, if they're here, we must need to configure them. And so there's a lot of useless alarms, a lot of useless information, and there's something important hiding in there. And so now there's a whole business, a whole industry growing up on simplifying alarm systems and bringing it back to the essential stuff that's tied to the process. And I think what goes wrong in many cases is, to further Cliff's comments, keeping a focus on what process phenomena we're trying to exploit for profit here is sometimes lost in the morass of software tools.
And finally, using capabilities that are one-off, using solutions that only one person in your company knows how to deal with, and then they're gone, that usually shuts things down pretty quick as well. And by the way, thank you all for making me feel really young today. I didn't start working until 1990.
Too soon old, too late smart, eh?
Just state your name and company.
Yeah, Keith Morrell, Savannah River Nuclear Solutions. Just a question. It's made up, it seems like this process, in order to effectively work, you have the R&D, you have the process control engineer, and you have the operators. Do you ever rotate your people through assignments there so they can build their skills, like have a process control automation engineer actually go out into the facility and work hand in hand with the operator for a month or so, and an R&D person do that? Do you rotate people through those assignments to help them build their skill set and understand the process better?
Absolutely. As a matter of fact, I'm trying to get some brand new process control engineers that we hired in within the last year or so to consider moving out into the plant. They're already partner with these people, but I'd now like to take that process control experience and go into the plant and get the run plant experience. And yes, we are trying to do that because it's that broad experience that gives them the perspective they need to come back and make some great impact in the process control area, or they might find they want to move further into operations.
Does that include the R&D people also going out into that, or do you have more resistance?
No, that's a little bit harder to do. As a matter of fact, when I went into manufacturing, I had people I loved and respected tell me not to go to the dark side. And it was the greatest decision I ever made was to go. So.
I was just thinking, it was something that was said earlier about building a plant. We know what crudes we're going to buy before we decide to build a refinery. We know about our chemical supply chain as part of the business case, the base case of building the structure. And we hire, good quality engineering firms to design and build and get all the physical structures in place, and they put in the process control systems, and they put in all the alarms. Yet these operators are forced to start up without the tools and the optimization. Like it almost seems like we have to start from scratch with this optimization journey once we've already put feedstocks in. So how can that be helped? How can we improve that? This is an open question to anybody on the panel.
I'll take the pause and jump in. Just, another thought that occurs is that, and it's just sort of a trend or a generalized a thing that we're seeing. A lot of our customers are making pretty heavy exploitation of operator training systems, and these systems have really evolved quite a lot in the last 10 years or so, and in as much as, you know, they can be, of course, they can freeze frame, rewind, you know, go many times real time. But one of the big things is that the fidelity has become much higher. And, you know, where they were maybe directionally correct to give somebody a sense of this, and we've actually seen folks use these operator training simulators, again, going back to the very straightforward example, conceptually at least, of the alarm systems, to use the operator training systems to you know, rationalize the alarms, if you will, before the plant is really commissioned or they turn it over. And I never thought I'd hear this, but I've actually had my customers tell me, owing to their confidence in the fidelity of the models, well, why don't you just do your step testing for your APC on the operator training system? We'll train the operators up on all the scenarios of the APC on the OTS, because it looked just like his DCS system. And then, you know, we have to make adjustments once it goes into place. So I see operator training systems playing an important role and an evolving role, you know, in some of these things.
I'll echo that a little bit. In my last job, I was trying to get the engineering folks to use operator training simulator in the design process to find out where the pinch points were that they weren't calculating in real state, in steady state rather. Interestingly enough, you know, they didn't do that, but they took the lesson away to start looking for those, and they found that, yeah, there was some changes in the process necessary, primarily because feedstocks had changed from the initial set of conditions. All bitumen is not the same, Peter.
Very quickly, process simulation, the capabilities today out of a lot of different providers have allowed us to now model aspects of our operations in Dow that we were not able to do even 10 years ago. And there are people still in the company saying, no, you really can't do that, it doesn't work, and wow, it does. So there's been huge advances, I think, in the last 10 years, and it's very encouraging.
I'd like to come at this a slightly different way. In a large, complex organization, it's very hard for people to know and understand how what they do every day can contribute to the success of their company. The business is complicated, the processes are complicated, the individual roles are so complex that you lose sight of why you're there, apart from, you know, enjoying playing with all of the technology. I was very fortunate when I started my career at Scott Paper Company. For some reason, people thought I had a lot of potential. In my first day on the job at Scott Paper in the Research and Engineering Division, our vice president called me into his office. I was a little scared because he was my boss's 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 boss, and I didn't understand why he wanted to talk to me. He sat me down, and he pulled out this printout stack of paper like this, and he started showing me case counts. And I sort of said, what is this? And he said, this is how many cases of toilet paper and how many cases of towel we shipped today, yesterday, the day before that, last month. And I said, why are you telling me this? And he explained. And when I left half an hour later, I still didn't understand what he was trying to tell me because I was scratching my head. You know, I had this really shiny new PhD. I'd already spent years in a plant, and I didn't understand what, but I thought about it. Why would this guy waste his time with a junior engineer? And I gradually started to understand what my role was supposed to be. Okay, it took a bit of effort. So companies don't do that. The problem is, if my boss had tried to, my boss couldn't have explained that to me. His boss couldn't have actually explained that to me. Maybe his boss could have, but this guy definitely could. Okay, and so in the end, if we're going to exploit technology in the most effective way, we have to make the people understand why they're being asked to do what they're doing and how they can use these tools to be most effective. Because they will know if they understand the overall goal and how they can contribute to the overall goal. That's what gets lost in really big, complex organizations with lots and lots of employees.
And then you can also ratchet that down to something that's meaningful to the operator and to the engineer on the process. One way we did that was calculate the what we called energy pars for every furnace in the plant. And the par was just like on golf. This is where it normally should be, and display that in real time, and then the operators would endeavor to try to beat par, and that made us money.
So I think
But
we've
make
got
it visible. The point is, you got to make it visible. It's like biofeedback. If there's no feedback, nobody will do anything.
a couple more questions. We're almost on the hour, so I want to make sure that I'm not dominating all the time. Just state your name and company, please.
It's Graf Gellstrom, Nova Chemicals. I know at our site the monthly plan before it gets published gets vetted through operations, so I'm going to say there's a little bit of sandbagging already built in to the monthly plan that comes out. And I know you said you regularly reconcile yours against actual, and I wonder if you're kind of building some sandbagging into your monthly plan, and if there's any idea of using this to say, well, now maybe I can update my monthly plans to a more aggressive plan based on what we found through this tool.
So let me get this straight. It was sandbagging on the monthly plan?
It's fat.
Well,
That's
and
fat,
there is.
right?
And what we've done is we're looking at that fat, and we're saying to ourselves that with the tool that we have, we can reduce what that fat is. But that takes time to look at that data, right? So we've been doing it now for a year, and it's now time to go and start looking at how much that's reduced. But talking to the planner, the production planner, and the whole team that's doing this, we felt that collaboratively that we have made a big difference, and we're operating a lot closer to plan and leaving less money on the table.
And one of the reasons that worked, or one of the reasons the problems arise, is because when we did the RTOs, those were nonlinear, very high fidelity, steady state models, and they were solved in an SQP, so they're quadratic. And your linear program is calculating your monthly plan, and it's linear, and it's got a bunch of correlations in it that aren't exactly up to date anymore because they were done about 10 years ago. And so there was always this disparity between what the optimizers were trying to do and what the LP was calculating. And one of the problems, we tried to address that, saying, well, let's take the best dollars economic information and then plug that into the objective function of the SQPs for the RTOs, and hopefully that'll drive us to where we need to go. But at the end of the month, there was always this gap that these guys have looked at, and we could never seem to resolve that because nobody really could understand why. And so technology was contributing to it, but it also wasn't, the causes weren't really visible. And another thing that contributed to that was I'd sit in a production meeting every morning, and I'd waste about the first half hour listening to the operations superintendent, the planner, and the maintenance guy all arguing about who had the right data. We finally solved that problem by putting in one data historian, so everybody had the same data, but the issue then became make it visible, make it understandable so that people can address the problem and get to the root causes.
I think I saw somebody else with their hand up. State your name and company.
Sure. Yeah, Hamid Zogby. I'm with BASF Corporation. Is there any examples you can give where some of this technology and process simulation or data, that we're utilizing, has been successfully used in predicting, downtime or unplanned downtime where it improves the overall asset effectiveness? We talked about improving yield and stuff like that, but what about the unforeseen?
I'll take that one. Yeah, we have a number of different examples on that. I can give you some just offhand here. On our alkylation unit, we're targeting to run a certain number, let's say 850, we'll call, maybe it's a little more, let's say 4,000 barrels a day, because I'm used to cubes a day. And we're not at that target. Why are we not at that target? Now what happened is we have outside sources of feedstock to this unit, and they've been disrupted because of problems that are happening outside of our refinery. With our profit meter, we can see exactly, just by integrating over time at where we should be and where we are today, what our losses are because of that. Okay, that's one example. Another example is our reformer. So we're running along and we're at the rates we're supposed to be at with our reformer, but we have a compressor failure. Now that compressor failure is unplanned, but with the profit meter, we can see exactly what that compressor failure was worth at the time it happened. So that gives you a lot of incentive to go and look at ways of improving the compressor, okay? It gives you dollar value associated with what's it worth to keep it running at a more optimal or a better level. So those are just like two of the examples. I hope that answers your question.
Another perspective on that kind of thing. We certainly, the discussion here, modeling and optimization and planning and scheduling. A number of our clients use these same kinds of models to predict heat exchanger cleaning, optimum intervals. They're used to predict and show material balance reconciliation. They're used to predict, catalyst end of life. Since I'm not for an operating company and I'm under about 20 NDAs, I can't go much further than that. But, these kind of, the modeling is sort of, cranked around to push those kinds of predictions out as well, which I think directly connect to the downtime.
Exactly, to expand. Basically, we are going to extend the lifetime of our plants. We're going to extend the lifetime between shutdowns. We're actually to the point now where we're avoiding periodic expected failures. Back to the fundamentals, back to process control. And I can't go into the details either, unfortunately, but it is clear that the old way of doing things on responding to the now maybe isn't working, and taking better advantage of our analytics throughout process simulation, through fundamentals and other things, is having a huge financial impact on us, positively.
Can I add one thing?
Yes, certainly,
Okay,
yes.
So, in my experience, just going back to this maintenance issue, unless there's catastrophic failures that everybody knows about, the nuisance failures tend to fall off the table at the annual budget meeting, where the refinery manager or plant manager and the different department managers sit down and fight out how they're going to divide up the money that headquarters allowed them. And so one thing that we've added to this, that again, it's all about people. So, I've been making technology all my life, but in the end, it's about the people. So now you add some more information that says, hey, this repair job or replacement of equipment that we all know we should do it. We just don't have enough money. But not doing it is worth X dollars. Okay, that's the new piece of information that's being added into that conversation, right? Whereas, if you lose the whole reformer, you know what that's worth. You're done for your gasoline production. But if you lose something that's only partially a problem, it's hard to put a value on it. So being able to put value on that and allowing the decision makers to have that additional information in the decision process is incredibly valuable and powerful. And that's really, in the end, all you're doing is adding some more information to the decision. In the end, the decision is still going to be made by those people. And they may still decide not to do it, right? But they know why they decided not to do it.
Okay, I think that just about wraps it up. I respect everybody's time. It is 12 o'clock, so please join me in a big round of applause for our experts. Thank you very much.